Alright, we're going to look at chapter 1.1 today, which is linear equations. So our objective is to solve linear and linear rational equations. This is something that you've had before, so it shouldn't be anything terribly new, maybe just a different way of looking at it. So an equation is a statement that says two expressions are equal. Before, we were just dealing with one side of the equation. And now we're going to look at both simultaneously. To solve an equation means to find all values of the variable that make the equation true. These values are called solutions or roots. We also call them zeros. Okay. So let's look at one. Something very, very simple. 3x plus 4 is equal to 16. Now, before we've talked about PEMDAS and the order of operations, and we do it this way. We do it this way when we are simplifying an expression. But when we are solving an equation for a variable, like we are in this case with x, we're going to do them in reverse. Okay, we're going to do these operations here in reverse. So the first thing I want to do is add or subtract. So I will subtract 4 and get 3x equals 12. And then we will multiply, divide. So divide by 3. And my answer would be 4. Now, of course, I can check these solutions, and you should, because here in a couple lessons, checking will be a must. So all I have to do is take this, plug it back in here, and see does it equal 16 or not. A linear equation in one variable can be written in the form ax squared plus b equals 0. And a cannot be 0. Well, if a is 0, this entire term goes away, and I just get b, a constant. Okay, and I can't do anything with a constant, so we have to have this a term. Now, I don't have to have a b term. I could have ax. I could have 3x equals 7. That is a linear equation. Okay, this is also a first-degree polynomial because my x is to the first power. Okay, so how do I know it's a linear equation? If you only have x to the first, that's linear. If you have x to any other power, it will not be linear. All right, so solve. Now, the first thing we want to do here is get rid of these parentheses. And how do I do that? Well, we'll take this negative here and negative here and distribute it inside. So we'll have 5x minus 7x plus 4 minus 2 equals 5, negative 3x minus 2. And if you notice, when I distributed, I did not rewrite my parentheses. They go away. So now we'll add like terms on each side. So I've got 5x minus 7x. So that's minus 2x. 4 minus 2 is 2. Equals minus 3x, 5 minus 2 is 3. So now I get to pick a side that I want x to go to. And it does not matter which side you move the x to and which side you move the numbers to. So let's add 3x to get x, and we'll subtract 2 equals 1. So your answer is x equals 1. Okay. Now, like I said, it doesn't matter what side you move the x to. Sometimes there are easier ways or easier sides to move it to, though. Okay, so we've got some fractions in here. But if you notice here, p is still to the first power, so this is still linear. Now, not very many people like to deal with the fractions, so we're going to get rid of them. Okay. And in order to get rid of them, we're going to multiply the entire thing by our greatest common denominator. Not our greatest, but our least common divisor. or our common denominator. And in this case, 5 is over 1. So if I look at all the denominators, okay, and if I were to make them all the same, they would all have to be a 4. So that's what I'm going to multiply by. And when I do that, I take this 4 and I distribute it into each term here. Okay, so I will have 4 times a half p minus 5 times 4 equals 4 times 3/4 p. Okay, well, half of 4 is 2p minus 20 equals that 4 and that 4 cancels 3p. So as you see, just by multiplying by my common denominator, all my fractions go away. I could have gotten a common denominator and combined like terms and done all that, but just get rid of all your fractions. So we'll subtract 2p minus 2p, negative 20 equals p. And we're done. So getting rid of those fractions right off the get-go kind of helps reduce some of the mistakes that you will probably make. Okay. Remember, when dealing with rational expressions, we must restrict the domain. Okay. So looking at this right here, I look at x in the bottom. Okay. And I got to say, well, x cannot equal 0. If it is 0, then I will get imaginary solutions, or not imaginary solutions, but I will get undefined solutions. Okay. Again, I don't like these fractions, so let's get rid of them. If we look down here, what would I make my common denominator be? Well, I know I've got to have an x with it. Okay. And look at our numbers. All of these go into 6. So then we'll take this 6 times all 4 of these terms. So I have 6x times 2 over 3 over 3x plus 6x times a half equals 6x times 4 over x plus 6x times 4/3. Okay, then I can kind of see what's going to cancel. Okay, with this one, let me change colors here. This will cancel with this. And my 6 will become a 2, and my 3 will become a 1. So I've got 2 times 2 is 4, plus, well, my 2 and my 6 cancel. So I've got 3x equals, my x and my x cancel. So I've got 6 times 4, which is 24, plus my 3 and my 6 cancel. So I have 8x. Now, if you can skip this long step here, you can. You don't have to write that out. So we'll minus 3x, you get 5x equals minus 24, minus 24, minus 20, and divide by 5. So x is minus 4. Now, does that go okay with my domain restriction of 0? Yes. Sometimes you will get answers down here that won't match your restriction. Those are what we call excluded values. So it's a solution that you will get that when you check it with your domain, or you check it here, will not work out. And we will see some of those. Okay, so here, let's right off the get-go, we see that x minus 1 is in the bottom. So that means that x cannot equal a 1. If it is a 1, 1 minus 1 is 0, and I can't have that. So now we will multiply the whole thing by my common denominator. Look at over here, my denominator. I noticed x plus 1, or x minus 1. I have a 1. I have an x minus 1. So we'll multiply everything by x minus 1. Okay. So then we'll say x minus 1 times 3x over x minus 1 plus x minus times 2 equals x minus 1 times 3 x minus 1. Well, this cancels with this, and this cancels with this. So I have 3x plus, distribute that 2 2x minus 2 equals 3. So something that looked pretty difficult, okay, pretty hard. Most of you would probably freeze up and skip this one. Now has become very, very simple. Okay, so now we'll just say that 5x minus 2 equals 3, plus 2 plus 2, 5x equals 5, divide by 5, and x equals 1. Super simple, okay? As long as we get rid of the fractions, we're good. But if we wait just a second and check our domain, we said that x could not be 1, but we got a 1. Okay? So in this case, this cannot be the solution, and we will say that there is no solution. So it is super important that we double check our domain, and if I were to plug this back in up here, we would figure out that I cannot have a solution. So in the beginning, this was a false statement. Okay, that had to be false in the beginning to get no solution down here. There could be imaginary solutions also. Okay, but we're not there yet. That's too far for us. All right, so looking at a little more difficult problem, the first thing I want to do is go through and factor everything out. Okay, so let's factor out 3. So you get x plus 6. That's gone. Factor out a 2, you get x plus 6. That's gone. Factor out an x, you get x plus 6. So looking at my restrictions here, we'll say that x cannot equal minus 6 and 0. So then we'll multiply the entire thing by my common denominator, which looks like it's going to be an x plus 6. Okay, but then I got a 2, a 3, and an x. 6x. All right, so we're taking this times all of these. So I've got 1s in the top, so that's good. So I'll have 6x, x plus 6 over 3x plus 6 minus 6x, x plus 6 over 2x plus 6 equals 6x over x plus x plus 6 over x plus 6. So now I get to do a little bit of canceling here. That's gone, that's gone, that's gone, that's gone, gone. 2 and 6 make 3, gone. 3 and 6 make 2. So I have 2x minus 3x equals 6. So that's minus x equals 6, so x is minus 6. But again, we had up here that x cannot be negative 6, so no solution. Okay, you really have to watch out for these no solution type problems. Okay. All right, let's hope to get a solution on this one. All right, so x cannot equal a 3 here and a 2 there. All right, so we're going to multiply the whole thing by x minus 3, 2 minus x. Okay, so I'm going to try to skip a step here. I want to take that in there. So if I look here, I've got x minus 3. So that cancels with this x minus 3. So I just have this 2 minus x. So I have 2 minus x equals, and in this case, I have minus 3 in the top, but this cancels this over here. So I have x minus 3. We'll distribute. 4 minus 2x equals negative 3x plus 9 plus 3x plus 3x, that's x, minus 4 minus 4 equals, that would be 5. So x equals 5. Can it equal 5? Yes, because it's not in my restrictions. So that is good. A car dealership charges for parts and an hourly rate for labor. If the parts cost $273, labor is $53 per hour, and the total bill is $458.50, how many hours did the dealership spend working on the car? So we're kind of looking into doing word problems. They will become a normal habit in here. Okay, so we have to set up equations for this word problem and for all my word problems. That's what we're looking for. Okay, the parts cost $273. That's not going to change. Labor is $53 per hour. So I've got to add to my parts $53 per hour, which is the X. So if I work X hours, I got to multiply it by 53. And I spent $458.50 on that bill. All I got to do is solve for X. So minus 273 minus 273, 53x equals, let's see, 458.50 minus 273, 185.50 divided by 53. X equals 3.5 hours. So he worked 3.5 hours. Now I can double check that. If I come here and say 273 plus 53 times 3.5 equals, and I say 458.50. Okay, so 3.5 hours. Word problems have to have a label. You will get it wrong if you do not have a label. Dante currently has the following 3 test scores, 82, 79, and 90. If the scores on the final exams were 2 test scores and his goal is to earn an 85 for his class average, what score in the final exam does Dante need to achieve his course goal? Okay, well, he wants an 85. Okay, and I need to find the average. To find an average, I take however many tests there are. So that's an 82, a 79, a 90, and I've got one more test, but it counts as double. So I've got 2x over the total number of tests. So there's 1, 2, 3, 4, 5 tests. This one counted as 2, so I have to add 2 to the total number of tests. So we'll solve it. So I'm going to multiply the whole thing by 5 again, because that's my denominator here. So, and I'm also going to add these 3 numbers. So 82 plus 79 plus 90. That's 251 plus 2x equals 85 times 5, 425. Okay, because this 5 went away with this one. Now minus 251, 2x equals 174, divide by 2, and x equals 87. He needs to get an 87, we'll say percent, let's say those were percent. He needs an 87 on this final to earn his 85 or his B in the class. Okay, this is a great problem. A lot of you, when we go to college, or when you go to college, and in my final, you will want to figure this out. Okay, and we will talk about this in class. This is a great example of how to use just simple linear modeling in real life. So chapter 1.1, page 99, here are your suggested problems. If you have questions, please let me know. As always, thanks for watching. This is at THS Mr. Jones signing off.